So see some processes, thermodynamic processes. Now in thermodynamic processes means what? It is when the system changes from one state to another state by following some path or by some operation, then we call it thermodynamic process. These are some types of processes: isothermal, adiabatic, isobaric, isochoric, reversible, irreversible. Isothermal means what? It is the process in which temperature is constant throughout the process. Then that process is a isothermal process. Adiabatic process in which no heat allows to enter the system or remove from the system throughout the process. Then this is the adiabatic process. Isobaric process, the process in which pressure is kept constant throughout the process. Throughout the process, pressure is kept constant. There will be no change in the process, no change in the pressure throughout the process. That process is called as isobaric process. Isochoric process in which volume is kept constant throughout the process. Throughout the process, volume is kept constant. Reversible process. In the reversible process is infinitesimally slow process. Infinitesimally slow process, and as we know that the two types of forces when the reaction is carried out, two types of forces are there: driving force and another is opposing force. Opposing force, driving force and opposing force. So driving force is what? Driving force is to carry out, to push the reaction or to carry out the reaction in forward direction. Okay, opposing force, this force opposes that driving force. So opposing force is for reverse direction. Okay, it opposes that process in forward direction. When driving force is infinitesimally greater than the opposing force. Driving force is only infinitesimally greater than the opposing force, so that reaction goes in forward direction, and at any point when we increase opposing force slightly, then reactions occurs in reverse direction, so that reaction becomes reversible. Okay, so in reversible process is an infinitesimally slow process in which driving force is infinitesimally slightly greater than the opposing force, so that at any point when we increase opposing force slightly, then the reactions occurs in reverse direction. That's why this reaction is called as the type of reaction is called as reversible reaction or reversible process. Okay, what happens in irreversible process? Irreversible process, the driving force and opposing force are a very large gap between these two forces. Driving force is very greater, so that there is no possibility of reversible reaction, and reaction cannot reverse, and that's why the reaction goes in forward direction only, and that process is a irreversible process. And all the natural processes are irreversible processes. So in practical, this reversible process is not possible. In practical, irreversible process is possible in reality, so that irreversible, all the natural processes are irreversible process. All the processes other than reversible process are irreversible processes. So these are about some thermodynamic processes: isothermal process, temperature constant; adiabatic process, no heat exchange; isobaric process, pressure constant; isochoric process, volume constant; reversible process, the driving force is slightly greater than the opposing force; irreversible process, driving force is and opposing force have very large difference, so that process cannot be reversed, and this process is a irreversible process. All the natural processes are irreversible processes. So this is all about thermodynamic processes. So these are thermodynamic processes. The next important point that we have to study is two types of differentials: exact differential and inexact differential. Exact differential and inexact differential. Inexact differential. Exact differential and inexact differential. So exact differential is for differential one whose differential leads to finite quantity. Whose differential leads to finite quantity. Such as, suppose we have taken here one quantity, that is internal energy. Okay, the small change in internal energy is indicated by du, or it may be indicated by, sometimes it is indicated by E. Energy is indicated by E or U, internal energy. So internal energy, small change indicated by du. If the system changes from A to B, initial to final state, then this differential, integral of this differential leads to finite quantity, that is UB minus UA. Okay, what is the difference? The difference is a finite difference delta U, and it is called as exact differential. So integral of this quantity leads to finite differential, then that differential is called as exact differential. Okay, integral of which leads to finite difference, then that quantity is called as exact differential. So exact differential is nothing but a state function, because exact differential depends on initial and final state of the system. So this is exact differential. See, inexact differential is what? One whose integral leads to total quantity. And not the difference. And it is path dependent. And this is path independent. Path dependent, and this is path independent. So inexact differential, one whose integral leads to total quantity, such as see work. So a small amount of work as a dW, when system changes from one state to another state, there will be change in the work, and this leads to total quantity W. Such as another is heat. Heat is also occurs during the process, and it is an inexact differential because whose integral leads to total quantity and not the difference. So it is path dependent function. So this function is called as inexact differential, and one whose integral leads to the difference, finite difference, that is an exact differential. Now the question on this topic may be what is exact differential, what is inexact differential, explained with example, or sometimes the question like this: sum of two inexact differential, sum of two inexact differential is exact differential. Sum of two inexact differential is exact differential. Explain. Sum of two inexact differential is exact differential. We have to explain this concept. How the sum of two inexact differential is exact differential. Okay. Suppose that consider internal energy. Internal energy is a state function. Okay. As we know that internal energy is a state function, so very small change in internal energy is indicated by du, internal energy change. When we consider the process in which system changes from state A to B, so this small change, integral of which leads to difference UB minus UA, so it is a total differential. Sorry, it is a finite difference. So it leads to finite difference. That's why it is an exact differential. So delta U is what? It is exact differential. exact differential. Okay, see another quantity. See another quantity. We have considered internal energy. Second, consider work done. Work done on system. So work done on system is indicated by small infinitesimal amount of work is indicated by delta W. So integral of this, when system changes from state A to B, integral of this leads to total quantity, not difference. So W is a total quantity and it is what? It leads to integral of which leads to total quantity. Then as per our definition, it is an inexact differential. So W is what? Inexact differential. Inexact differential. Okay. So another quantity, heat exchanged. Okay. Heat exchanged. Heat exchange. So heat is indicated by this symbol. Infinitesimal change in the heat is indicated by delta Q. So integral of which, when system changes from state A to B, so integral of this quantity leads to total quantity, that is Q. Okay, and not the difference, because this one is also inexact differential. This one is inexact differential. Inexact differential. So inexact internal energy is exact differential, work done on the system is inexact differential, and heat is also inexact differential. So according to first law of thermodynamics that we have to study in next lectures, first law of thermodynamics. What first law of thermodynamics says? First law of thermodynamics says, first law of thermodynamics for expansion, delta U is equal to Q plus W. So this is mathematical expression for first law of thermodynamics. This is mathematical expression for first law of thermodynamics. Delta U is equal to Q plus W, and as per we know that delta U, as we derived, delta U is what? It is exact differential. Q is what? Q is inexact differential. Inexact differential. Q is inexact differential. And next, W plus W is also inexact differential. Okay, so exact differential, inexact plus inexact. That means exact differential is the summation of two inexact differential. So our question solves here. Sum of two inexact differential, sum of two inexact differential is exact differential. So we can say from the first statement of first law of thermodynamics that sum of two inexact differential is exact differential. Sum of two inexact differential is exact differential. Next, the term we have to study is the total differential. Okay. We saw exact differential, inexact differential, then important quantity, important term in thermodynamics that we have to study is the total differential. Now total differential is what? See the total differential. Total differential, this term is used when any function dependent on another variables. Suppose that psi is a function. Okay, is any function psi which depends on two quantities x, y. If psi is a dependent function on x, y, then the total differential indicated by d psi is given. So d psi is the total differential. Okay, which is given in this way. So delta psi, differential of this quantity delta psi with respect to delta y, with respect to one quantity, keeping another quantity constant into dy, again derivative of this quantity, plus delta psi with respect to first quantity delta x at constant y into dx. So total differential dy d psi can be obtained in this way. We can this function is dependent only on two quantities. It may be on three quantities, on four quantities. Suppose that psi is a function of or dependent on x, y, z, three quantities. Then how can we define? How can we derive the total differential? The total differential is d psi. Okay, d psi is a total differential. So total differential d psi is what? D delta psi with respect to delta z at constant x and y into dz plus delta psi into, by now keep other two quantities constant and take derivative of this delta psi into delta y at constant x and constant z into dy plus delta psi into delta x at constant at constant y and constant z into dx. So in this way we can find out the total differential of any quantity which depends on other quantities, maybe 2, maybe 3, maybe 4. So total differential we can find out. Suppose that we have taken example here, if internal energy U dependent on volume and temperature. If internal energy U dependent on volume and temperature, then how can we find out the total differential for this quantity, internal energy, total internal energy? So total differential for internal energy, that is dU, is equal to delta U by delta V at constant T into dV. We have taken differential of first quantity by keeping second quantity constant, okay, with respect to dV, plus now take differential with respect to second quantity by keeping first quantity constant with respect to dt. So this gives the total differential. Okay, total differential. Now this quantity delta U by delta V at constant T gives the partial differentiation. This is called as partial differential with respect to V at constant temperature. Means U changes with respect to V. Internal energy changes with respect to volume at constant temperature. So this is the total differential and this is partial differentiation. Means total differentiation is what? Total differential is the summation of all the partial differentials. Okay, summation of all the partial differentiation give the total differential, and it is important quantity because we have to apply this equation in many other equations in thermodynamics. So it is important, that is total differential. Okay, so next we have to study the important law of thermodynamics. We have to start the actual syllabus because we in last lectures we have studied the basic terms required to understand the thermodynamics. In order to understand the thermodynamics, we saw the basic terms because they are must. You must know these terms in order to understand thermodynamics. In actual, we have to start this important topic of the thermodynamics. And